Olivia with Prepaze, and today we'll be going over functions with respect to lines. So in our past video, we were working with a parabola, an x squared value, and so our skateboarder was doing all kinds of hops. But for the rest of our function units, we're going to be working exclusively with lines. Now, in this video, I'm going to be using the same function way back from our episode 3, which is y equals 2x but plus 3. The wonderful thing about lines is that there's a constant rate of change between one value and the next value, one input to the next input. And I'm going to explain that more in depth in this video. So I filled in the missing values from the episode 3 video. So if you didn't fill that out, here's your little cheat sheet. And here we've got a set of ordered pairs. Our x value, that produces our y value. So we've got 1 makes 5 with this function, 3 halves makes 6, 3 makes 7, and 7 makes 17. Now we're going to talk about the constant rate of change as a ratio between how much vertical change compares to how much horizontal change is happening. Or for our graphs, how much change is happening in the vertical direction versus the horizontal direction. So let's take our last two columns for this example. So I've got 3, 9, and 7, 17. So to talk about the horizontal distance between these two values, I'm going to be looking at the 3 and the 7. So the distance between these two values is going to be the difference. We went from a 3 to a 7, so we've moved 4 horizontally in that direction. So 4 horizontal movement. In the vertical direction, we have the difference between 17 and 9. And for that would give us the result of 8. Now, like I said before, we express this rate of change as a ratio of the horizontal movement to, of the vertical movement to the horizontal movement. And so vertical movement is 8 in this case, and we divide by the horizontal movement. 8 divided by 4, change in vertical over change in horizontal, change in output over change in input. 8 divided by 4 would be 2 in this case. Now, notice I said constant rate of change. So let's look at another 2 pairs of points on this line and see if we get the same result, the rate of change being 2, equivalent to 8 over 4. So the 2 points we're going to consider this time are 1, 5 and 3, 9. Horizontal movement is going to be characterized by the distance between our first values, 3 to 1, which is we increase by 2 to get from 1 to 3. To get from 5 to 9, we increase by 4. Our ratio is vertical to horizontal over horizontal, changes in y's over changes in x's, changes in outputs over changes in inputs. This is all the same language. In this case, we would have 4 divided by 2, which is again 2. So we're ending up with the same equation, and that means you take any 2 points on this line, you'll find that that rate of change, the change in output with the relationship to the change in input, is always going to be 2. And that's the characteristic of our lines. Notice that in our expression here, y equals 2x plus 3, 2 happens to be the value that is being multiplied by x. So this was a way that we could show our work and confirm that the distance between 2 points will always be 2. And if we don't have the equation of our line, this is the strategy to do it. However, if you have your equation of your line, it's typically going to be the value that is multiplied by x if it's in this form. We'll talk more about slope-intercept form in the next video. So just to summarize everything that we talked about today, we are finding out that the equation of lines will always output this constant rate of change. And that constant rate of change is our distance in our vertical movement, our output, or our changes in y, divided by our changes in our input, horizontal movement, or x's. This little equation here, rate of change is equal to y2 minus y1 over x2 minus x1. It's really helpful because it helps us keep consistently identifying what is our first point and what is our second point. In this case, we have increasing values, so our larger value is going to be the minuend, and the smaller value will be the subtrahend. Thank you so much for joining me on this ride. Go ahead and look at some lines yourself, look at some tables, and see if you can put together an equation of a line or find your rate of change. And I will see you guys in the next video.